recording. Okay, 13.5 transformers. Well, let's just read the definition of transformers. An electromagnetic device that can raise or lower voltage. This is useful for places like Europe where we need adapters in outlets to accommodate our electrical devices. So in Europe, it's not the same as 120 volts like in Canada, right? You're taking your devices to the Europes, there is no use over there. You cannot use the like plugs, right, to use your device. So you have to use the transformers. If over there the voltage is 100 and here is 120 or 240 here, you need to use a step down transformers to decreasing the voltage. If you're going to another country that have more voltage than our country, so you use the step up transformers. Kind of you go to a store and tell them, hey, I want to go to Europe and use my appliance. So they will give you, they know which transformers give to you, right? So the technicians know what you need and will give it to you. So it's better that you know what's happening, right? So step down transformers, fewer secondary winding than primary winding. So this is the primary winding, right? Here. Primary winding is when you just connect this one into let's say the outlets. And here the secondary coil is the end that you are um, connecting to your device. Okay, so it's just let's say 120 is here, so it's lowered down to 100 for you. So you can use that using your device in other countries. Anyway, so and you see we have windings for a step down. You have more windings on primary coil. So then um, secondary coil. And in step up, you have fewer windings or loops in primary coil than secondary. Okay. You see there is a soft iron core here. So here is the equation. If you want to do some calculation, you know, the voltage of the primary divided by the voltage of secondary give you equal to the current inside secondary coil divided by current inside primary coil. And this is equal to number of windings in primary coils divided by number of secondary and number of windings in secondary coils. Okay. And we'll use that just an example. You will use this lovely equation. Now, a step down transformer used in an adapter for a laptop has a primary voltage. So then we have V of P is 120 volts. There are 250 winding in primary. So N of P is 200, 250. Cool. And 25 winding is a secondary. So V of the primary, yeah, V of S is 25. And secondary coil. Calculate the voltage. Oh, sorry, this is the winding, what I did. We have 25 winding in second, so N of S. Calculate the voltage in the secondary, so we want to find Vs. So knowing that this equation Vp over V of what secondary is equal to what I in secondary divided by I in primary equal to N is primary divided by N is secondary. So as you see for the N's is kind of direct relationship. This is P here, this is P here, and S here is S here. But for current is kind of if this P is gonna be S, like it's reverse. Now I need to use the first one and the last one because we just have V and P's, right? And then V's. So I'm gonna use that relation. VP over VS is equal to NP over NS. Now VP is 120 divided by what? 120 volts divided by VLS. I want to find it out. And then N of P is 250. Sorry, vice versa. So it's going to be N of P, right? Yeah. N of P, V of P. Okay, I was right. 250. And N of S is 25. Okay, so V of S, cross that goes to denominator, 250 goes down. And these two cross each other goes to numerator. So it's 25, this is 10, 0 here and 0 here goes, and it's going to be 12. Okay, so it makes sense. This is a step down. If this is 120, it's a stepping down 12 to the 12 volts. Okay, because this is a step down transformers. Noticing that your windings going 10 down, 10 times smaller, then your voltage will be 10 times smaller, right? Makes sense. Any question? No? Now again, another question with a step down transformers that you are using for cell phone chargers has a primary voltage VP of 120 volts and a secondary voltage 5 volts. The current in a primary coil is 0.1. IP is 0.1 amp. Calculate the current in secondary coil, IS. So we use that relationship VP over VS is IS over P. Oh, IS over IP. So VP is 120 volts, VS is 5, IS I want to find it, and IP is 0.1. Just cross multiplication, these two go in numerator. Here is divided by 5. So if you multiply that, maybe 12 over 5, it's going to be amp, right? So you see, kind of a step down means your current is going down too, right? Any question? Okay, so let me stop this.